Okay, for time less than 10, an alternate model. I remember other AP practice problems like this. So another way to measure the internal temperature of the potato is a function called G that satisfies this different differential equation. This is a perfect example of why you have to read really carefully. So now we're talking about a way to measure temperature. So temperature is an amount. That method is G. Temperature is different at different times. That's why we write G of T. And we have a new equation for the rate at which the temperature of the potato will change. That's dG over dt. This is negative G subtract 27 to the 2/3 power. G is still measured in degrees Celsius. G of 0 is still 91. Find an expression G of T. Got it. That's this statement here, that we use the SASSY method whenever we're trying to find an amount formula from a rate formula. So we know this formula here, we're trying to get to this formula here. The method of doing that is the SASSY method. I don't want to keep reading. There's going to be another question here. There's no reason to keep going because it said find an expression for G of T. So let's get working on that. So we're going to make a new page here. So we've got dG over dt is equal to negative parenthesis G minus 27 to the 2/3. G minus 27 to the 2/3 power. Cool. All right, so first step is to separate, which means the very first thing I do is always multiply both sides by dt. Now I will divide both sides by this thing. So you get 1 over. The negative can kind of go wherever I want it to go. It doesn't really matter because it's just -1 multiplied by. So I'm going to just leave this. I don't really know which way is better, so this will have to do for now. 2/3 dG is going to equal -1 dt. If I get that far, I get 1 point for correctly separating the variables. Now it's time to find the antiderivative of both halves. Can't really find the antiderivative with this in the denominator, so I rewrite it as the antiderivative of G subtract 27 raised to the negative 2/3 power dG is going to equal antiderivative -1 dt. This is going to require the expanded power rule, but the A, so remember the expanded power rule looks like this. Antiderivative AX plus B to the n dx. So my A in this case is simply 1. The B is -27. The X is the G. And the dx is the dG. So using that rule, I'm going to get this antiderivative is 1 over A, parenthesis, G subtract 27 to the negative 2/3 plus 1, all divided by the same, negative 2/3 plus 1. Equals, the antiderivative of -1 is just -1t, and then I have my constant. Get that far, get one more point. And now we want to find the constant. So let's clean this up a little bit. This is going to be g subtract 27. Negative 2/3 plus 1 is positive 1/3. So that's divided by positive 1/3 equals negative t plus c. Dividing by a third is the same as multiplying by 3. So now what we have is 3 multiplied by g subtract 27 to the 1/3 power, is all equal to negative t plus c. They told us at the beginning that G at time 0 had a temperature of 91. So that means 3, plug in 0 for the temperature is 91, minus 27, the 1/3 power must equal negative, put in parentheses for t, like that. So now I have 3. Use my calculator. This turned out to be 64. The 1/3 power equals c. You can actually leave it like that. That's actually quite safe. Having a calculator available to me, I just want to save a little writing later. 64 to the 1/3 power means the cube root of 64, which is 4. 3 times 4 is 12. So I have found the value of c. Either one is fine, though. This stopping right there is fine. Stopping right there is fine. You get 1 point here for plugging in this information. And then you get a second point for getting to here. So we've earned, so far, 4 points on this problem. The last step now is to find, they're actually different on this one, my bad. They switched it up a little bit. 1 point total for doing that. So 1 point total for that section in green. So 1 point for getting to here and finding c. So now to isolate, we go back to this equation here, and we write 3 times g subtract. Remember, the isolate step is often the one that takes the longest, so not a bad idea to, at this point, move on to a new problem, come back to this one later, plus 12. This one's not too bad. So we divide both sides by 3. And then we, to get rid of the 1/3 power, we cube both sides. So that gives you g minus 27 is equal to this. Final answer is going to be g of t is equal to 27 plus negative t plus 12 all over 3 cubed. That's another point for getting that far. Then, if you remember the question way back here, so now we found the expression for g based on this model. So based on g of t, what is the temperature of the potato at time 3? This means we want to plug in a time equal 3 into our equation right here. Now we don't have to simplify anything, so we could just write on the paper g of 3 is going to equal 27 plus, parenthesis, don't forget the negative there, time is 3 plus 12, all divided by 3, and all of that cubed, and I would put a degree Celsius there, and I would quit. And that would be 1 point. I do not want to take any more time, don't want to risk any other mistake there. And that's it. If you kept going, it turned out to be 54. But you really should have stopped. I kept going up here just because it got a little bit cumbersome sometimes to carry around big expressions. But at this point, there's nothing more to do, so I would stop there. So 5 points total for this part C. Once again, the points were awarded as 1 point for separating, 1 point for finding the antiderivatives, 1 point for plugging in the initial condition here and finding C. That was here or here. So 1 point total for that. 1 more point for isolating, getting the G of t alone. And 1 final point for plugging a 3 into that G of t equation. So a total of 5.